welcome to this new chapter. In this chapter, we'll be looking at vectors. In particular, adding and subtracting vectors and multiplying them by scalars, representing them as column vectors, and otherwise magnitude and direction of vectors, position vectors, solving geometric problems involving vectors, and modeling with vectors. So I've said a few words that you may be already unfamiliar with, like a scalar and magnitude and direction. So I've created this questions and answers here. All you have to do is read each bullet point matches up with one of these numbered definitions. So pause the video, try to just jot down what you think the definition and uh, the red word is, and then I'll show you the answer. Okay, so by now I hope you've paused the video and you've had a go at these questions. So what does magnitude mean? So vectors have they define two important pieces of information for us. One of them is how long the vector is and what the direction it's pointing towards. So a vector may have different lengths. So magnitude is just another word for its length or its size. Okay, so magnitude means its size. Then scalar, what's the meaning of scalar? A scalar is just a quantity, it's a number that you multiply, or it's like a scale factor, right? It's a constant that you multiply each component of a vector. Now, all right, resultant vector. If you hear the word resultant vector, that means when we adding two or more vectors, vectors can be representing forces, so the final result when you add them is a representation of multiple vectors in one vector. So it means the result, basically. Result of adding more than one vector, or multiplying and then adding them together. All right, so multiplying by a scalar and adding them together. So vector, what is the definition of vector? It's a directed quantity. It means that for vectors in two direction, you can write them like 2, 3 in this column notation. It means that it's traveling in 2 units in x direction, and it's positive, so it's going to the right, and it's going up by 3 units here. Now, this same vector can be written as, this is called the column notation, because we've written one above the other. X is always go on top of y. They don't put a fraction line, anything, that's it. So it may also be written as 2i plus 3j. This is another way of writing vector. If it's not in column notation and we writing it in a line, then we put the value of I here. I always travels in x direction, and j indicates that we are talking about the direction of y. Okay, so a scalar multiple, I briefly said something about it. It's another word for actually a scalar. I don't know why it's repeated there. Okay, so a scalar multiple vector, so it means that a parallel vector. So we'll discuss how to determine if two vectors are parallel or not. But if one is a scalar multiple of the other, they're parallel. So I already have written this vector 2 comma 3, or 2i plus 3j. All right, so what is another vector that's parallel to that? For example, I could say minus 2i minus 3j is parallel to that, because I multiplied everything by minus. So basically that was pointing up and to the left. Now this other vector here is pointing down and to the, sorry, that was pointing up and to the right. This is pointing down and to the left, but they will be parallel because of the coefficients of I and j are just exact multiple of each other. All right, let's do another one. Is 4i plus 6j. All right, so this is where the vectors are parallel with each other, only the magnitude is different. This other vector, this new vector here, is just twice as long. The magnitude is longer, but it's pointing the same direction because the ratio of I to j is exactly the same. If I simplify 2 dot dot, if I simplify 4 dot dot 6, I get 2 dot dot 3. You can think of it as the ratio that's telling us the direction. The ratio tells us the direction, and I'll tell you how to find the magnitude later. Okay, so displacement, this is just a word related to applied maths and physics. So displacement is a distance combined with direction, all right? And velocity, another word from applied maths, is the speed combined with direction, velocity. Column vector, I briefly said something about it. It's a horizontal. This is the column vector. When you write it in this format, that's the column vector. All right, so that was just a quick definition of a few new words that we have here. And now I suggest you pause the video and have a go at these questions again. And once you have had a go, I'll show you the answer. Okay, so I hope you've tried this by now. So it's question 1a is just asking what is the righted vector, column vector, like I said, that will take shape A to B. So it doesn't matter which corner of A you choose, as long as you match it with corresponding corner of B. So I've taken the bottom right corner. So you're saying that how many units, you need to say how many units up, first of all, left to right. So vectors, the top number is actually representing the left to right direction, and then the bottom number here is up and down. When we did translations, we did write these vectors already when I was defining translations. If you remember, we sometimes put 0 and A when like we had translation in y direction, remember? So that was a vector. So here is 4 units to the right and 2 units up, A to B. So you're gonna have 4 here and 2 here. So let's write it nice and neat here, like so. So A to C, have a go at this. So how many, doesn't matter which corner you take, you could just take the top right corner, top left corner. You say that moved 5 units to the right and 2 units down. So 5 minus 2. All right. And A to D. A to D is 1 to the left and 3 down. So 1 minus 3, minus 1 minus 3. So moving to the left direction means minus 1. Moving down means minus 3. Okay. So for question 2, divide the P divides line AB in a ratio of 7 to 2, basically. So draw yourself a picture. Just this is A to B, all right, and we're saying P is somewhere along this line, so that it's A to P is 7 times larger than twice P to V. So it's something like so, somewhere along the line like that, where this distance is 7 units and this distance between P to V is 2 units. All right, that's all it means. Now it's saying that what is this fraction? A to P, 7 over 9, because A to B counts as 9, doesn't it? So 7 over 9 because A to B is 9 units. And then 2 over 9, and what do you think? It's going to be 7 over 2, right? And then for question 3, pause the video. These are just trigonometric questions that you have to answer. You using sine and cos rule here. So think which one applies and have a go at them. So that these are the answers you should have come up with. So what's in this question may be challenging you here. This to tell you you can use the sine rule to figure out this angle here, but this angle here will give you that length here. Our axis means that you actually need to figure out what's this missing angle here first. You say these two add up to 100, and I know that therefore that angle is 80. So you need to use the sine rule with 80 degrees rather than 30 to figure out this x, okay? Alright, so I'll see you in the next video.